Hello everyone. Happy Friday. Hope you're doing well. Sorry I can't be here, but I hope you're carrying along okay without me. You should have started by checking yesterday's homework. Hopefully our guest teacher put up the solutions to those so you can check your work, and then I'll be taking those for credit when I get back on the next school day. So make sure that you went through those, circled ones that you had questions on so that we can address those in an efficient manner on Monday. To start then, please, if you would, have the notes out for Chapter 7, the very last day, 7.6. It actually is 2 pages in your note packet. So have your note packet out to that. I think there's a typo actually in the note packet. It says 7.5. It says it for both days. It should be the one that says in your note packet 7.5 solve systems of linear inequalities. It should be 7.6. So that's a typo on my part. So have your note packet out, and then wherever you've done your homework in your notebook or on a scratch piece of paper, our warm-up question to start is the following. I want you to state which method is the best to solve the following system of equations, and then actually go through and solve that system of equations with that method. So choose one of the two and choose one of our 3 tools, either graphing, substitution, or elimination to solve one of the 2 questions. You only need to do one, and then we'll come back to it. So we're going to take about 3 minutes to pause the video now, give everyone a chance to try the question of their choice, and then interpret what the answer means according to what we did yesterday. So pause the video now. Okay, welcome back. Let's go through these. So the very first one, I would probably choose to solve that one by substitution. The reason I would probably try to choose that one to do by substitution is because the variable y is already by itself here. So I take what I know about y and I maybe substitute it into the second equation. So I'm going to plop it, boom, right in to the first equation, substituting it in there. Then after I substitute in, I distribute. Once I've distributed, then I combine my like terms. I get 4x minus 4x plus 16. Well, 4x minus 4x is 0 x's, and I get a statement of 16 equals 16. And because that's a true statement, it's saying it doesn't matter what the variable x was. Those 2 lines are always going to be crossing. They are actually the exact same line. If you had solved equation y up here, if you had solved the first equation for y, you would have got the exact same equation as equation 2 because they're the exact same line. Since we got a true statement, we have infinite solutions. Second one, I would probably choose to solve that by elimination because they have the same number of x's and y's. Doesn't matter which one I choose to eliminate. I would add them both because they are opposite in sign. When I add them both, my x's disappear and my y's disappear. And because they both disappear, what I end up with is 0 on the left-hand side. I get 10 on the right-hand side, and that's a false statement. 0 does not equal 10. It's saying it doesn't matter what x and y are. Those 2 lines are never going to cross. Those 2 lines, if you graph them, are actually parallel. There is no solution. There is no point of intersection, so my algebra skills are going to fail me because there is no point where they cross. That is a review of what we did yesterday. You either get true statements or false statements, or you get a solution because they do cross, but they only cross in one point. Moving on to what we're looking at today, this whole chapter has been on trying to find where 2 lines cross. Now what we're going to do is we're going to try to find where 2 inequalities overlap. So what we're going to do is we're going to start by recalling what we did last chapter. So at the top of your notes, there's 2 graphs for you to do. We're going to graph these inequalities. So I'm going to graph negative x minus 2, and y is greater than that statement. So I get my writing utensil out. This guy has a y-intercept of negative 2, so I come down here, put down negative 2. The slope right here is a 1 in front of that, so it's a negative 1 is my slope. Because negative 1 is my slope, what I'm going to do is go down 1, right 1, down 1, right 1, down 1, right 1. With that, then I can sketch in a line. So I'm going to sketch in my line. It'll look, I'm going to do that, and I'm going to move it up. So there's my line. Put some arrows on it because it is a line, it's not a segment. So there's my boundary line, and then if I look up here, it actually should be dashed because it's just greater than. So I'd go back through and I would erase this, make this be dashed. So you go back through, erase part of it because it should be a dashed boundary line. Now with a dashed boundary line, I want all of my y's bigger than that line, or I could test 0, 0. If I test 0, 0, I get 0 is greater than negative 2, and that's a true statement. Because that's a true statement, it says this side works. I'm going to shade everything above that line. Now we're going to do a second one. So I come over here, we're going to do a second one. Want to graph this one. This has a y-intercept of 6. So I put down y-intercept of 6. It has a slope of 3, so I go up 1, 2, 3, right 1. And go back or go down 1, 2, 3, left 1, because negative 3 divided by negative 1 is the exact same thing. And then I graph my boundary line. So graph my boundary line here. Move it just to fit it a little better. There's my boundary line. This one's okay that it's solid, and the reason it's okay that it's a solid boundary line is because it can be equal to. So there's my boundary line. Now I want everything less than that boundary line, or I test 0, 0 here. Test this point. Because 0 is less than or equal to, if I put 0 in for x and 0 in for y, this is going to disappear. I get 0 is less than or equal to 6. That is a true statement, so I want to be below that line. That is our old skill. This whole chapter, we've been trying to find where two lines cross. We're going to extend that and say, can I do it and try to find where two inequalities overlap? It's like we're saying, where do two inequalities cross? What we're going to do is we're going to take these two graphs that we've just done, we're going to put them together. So here's my two graphs that we just did. There's my first one. Here's my second one. And what we're going to do is we're going to put them together. So what I'm going to do is I'm going to take them and I'm going to overlap them. So if I grab one of these and put it over the top of them, it looks like this. So I'm graphing both, and I want to see where do they overlap. What points make both inequalities true? Just like when we were graphing two lines and trying to find their point of intersection, we said what 2 points make both are on both lines. Now we're going to say what 2 points are on both inequalities. So I want the set of points that are going to be above this green line and below the blue line. And the set of points that do that are right here. These are my points that are above my green but below my blue. So these are the actual points that I would shade in. This blue and this red is just there for this picture, but when you are graphing them on your own, what you do is you graph both boundary lines and then you only shade in the one that makes both of them true. So the only parts that I would shade in here are going to be the black ones. So on your notes, your job is to regraph those two boundary lines and then shade in this section right here that I did in black. Those are the points that make both inequalities true. Okay, now what we're going to do is we're going to test some of the points, just like they say in the notes. It asks, which of the following are solutions to both, and it gives us some options. Is 0, 0 going to make both of the inequalities true statements? And it will, because 0, 0 is in both shaded regions. If I come in right here, 0, 0 is right there. That is going to work. What about the next one? Option B. Is negative 2, 0 going to work? If I come over here and I look at negative 2, 0, oh, I can see it works because it's on the blue line. However, it is not strictly above the green line, so it's going to fail this one. If I put negative 2 in for x here and 0 in for y, I'm going to get a false statement because I'm going to end up with 0 is greater than 0, and that's not a true statement. So this point, negative 2, 0, is not making both of them true because it's on the dashed line. I can't be on the dashed line. Does it work for this third point? Does it work for maybe 1 and negative 2.99999? So if I go over to 1 and down to negative 2.99999, yeah, it's just above my dashed line. Because it's just above my dashed line, it means I'm not on it. I'm okay. That point, 1, negative 2.9999 works. It is in my shaded region. It is not on my green dashed line here. What about the very last one? What if I check negative 1, 3? So if I go left 1 and up 1, 2, 3, that point is on this blue line. And because the blue line is solid, I can be on that and it'll work. It would be one of my points that are in my black shaded in region. So that one works as well. So the only one that does not work is B. Any other point I pick out here, if I pick this point right here, 1, 2, 3, 4, 5 for x and 1, 2, 3, 4 for y, if I put in 5 for x and 4 in for y into both of these inequalities, it would make both of them true. So that's what we're doing. We're graphing linear inequalities, seeing which ones make both true. We're going to try Another one. So if I were to graph y is less than x minus 4 and y is greater than or equal to negative 1x plus 3, here are my following steps. And the steps are already written in your notes. Step 1 is graph each inequality's boundary line. And that's already done for us. If I look here, this guy has a y-intercept of negative 4, and that's right here. It has a slope of 1, so I go up one, right one, up one, right one. So there's my boundary line that I've done here in green. So this is my green boundary line. It's dashed because it's not an equal to. Here, my next one is my purple one. My purple one has a y-intercept of 3, which it should, and it has a slope of negative 1, down one, right one, down one, right one. It's solid because it's equal to. So I've done both my boundary lines, and then what I've done is I've shaded in the region that makes both true. And the region that does that is the one that's below my green line and above, because it's greater than, my purple line. And the only region that is below my green and above my purple is this region right here. So I'm going to get it in black. It's all the points that are below my green line and on. I can be on my purple line because it's solid, or above my purple line. So all of these, this would be my complete shaded in region. It's the shaded region that overlaps the two. Your turn then to try. So you pull out your whiteboards, please, and then on the back side, graph both of these inequalities and then shade in the region, only the region that makes both of them true. So you're going to need probably the region below this first line and above or on the second line. So on your whiteboards, try it. Pause the video now. Give everyone maybe 3 minutes to try it. I'll come back. I'm going to graph it in Desmos and then show you so you can compare. So pause the video now, please. Okay, welcome back. Let's go and type this in. So this first one is y is less than 2x minus 4. So I'm going to go and type y is less than 2x minus 4. There's my first shaded in region. Now I'm going to go back. What was my other one? My other one was y is greater than or equal to negative x plus 5. Y is greater than, and then I can type an equal to, and it knows, negative x plus 5. Is that right? Negative x plus 5 it is. And I look. What's the region that is shaded in by both of them? It should be the region that is below my red line and above my blue. And you can kind of see Desmos is making that the purple. So the region that you should only have shaded in, the only region you should have shaded in is this purple region over here. It's the one that overlaps the blue and the red. Desmos is just showing you both here to show you. But when you're showing your work, the only region that should be shaded in is this region right here, the one that's below this dashed red line and either on or above the blue line, and Desmos is doing that in purple. So the purple region should be the only one that you had shaded in on your whiteboard. Okay, hopefully that went okay. Moving forward. Next thing is we're going to do is we're going to ask the backward question. Instead of me telling you the equations for the inequalities and asking you to graph it, I want you to tell me what two inequalities could be combined to make the graph. It's the backward question. So if I look at this, we call this the feasible region. It's the area that's shaded in by both. I want the one that is to the left or less than this green line, and that is above or greater than the purple line. So I need the equations for both of the boundary lines at start. So if I look at this first one, this boundary line, I'm going to write the equation for the line at first. This boundary line is a vertical line, and I know every single vertical line has the same x-coordinate. Like this point has the coordinate 1, 2, 3, down 2. So 3, negative 2. That coordinate right there is 3, negative 3. This coordinate right here is 3, and then up 1, 2, 3, 4, 5, 6, 7. That's 3, 7. Every single coordinate has an x-coordinate of 3, so this boundary line is x equals 3. I'll worry about the inequality here in a second. This purple boundary line, it has a y-intercept of negative 1. It has a slope of, looks like, let's see, it's kind of hard to tell because it's kind of a fat line, but it looks to me like it's up 1, 2, and right 3 before it crosses again. So it has a y-intercept of negative 1 and a slope of up 2, right 3. So let's write that down. I know its intercept b is equal to negative 1, and I know its slope m is equal to up 2, right 3. So I'm going to write that equation. The equation for this purple boundary line is y equals 2/3 x, because that's the slope, minus 1. So there is my purple boundary line. Here's my green boundary line. Now I need them to be inequalities, so I'm going to worry about less thans and greater thans and all the equal to parts right now. So I want the one that is to the left of my green line. If it's going to be left of my green line, I need x. I want all my x's less than 3. So that will give me everything to the left of this green line, and I need all the points that are above the purple line and cannot be on the purple line. So if it's going to be above, it has to be greater, and because it's a dashed purple line, I'm not going to put equal to. So it has to be above the line 2/3 x minus 1. And that, if I graphed both of those, would give me the graph to the left. All of these points will make both of these true. It's all the points that are to the left of that green boundary line and above that purple boundary line. So that's the backward question. There's two things I can ask you. I can ask you to graph it, just like you did here. If I give you this system, and I'm going to also ask you to be more clever, because if you can do both ways, you really understand it. I'll give you the picture and ask you to describe what inequalities would make that picture. Now you try. So on the whiteboard, here's the graph. You don't need to graph it. I already given you the graph. Your job is to take 2 minutes, write down what two inequalities would make the following graphs. Pause the video now for 2 minutes, compare with your neighbor, talk it out, and we'll come back here in 2 minutes. Okay, welcome back. Let's start. This first one's a vertical line. It's a vertical line through x equals 2, and I need to be to the left of this boundary line. So boundary line is x equals 2. I need to be to the left of it. So my yellow equation, is this going to show up? No, it's not going to show up very well. So we're going to alter. This yellow equation is going to be, I want to be to the left of x equals 2, so I need to be left or less than 2. This green boundary line is y equals 1, 2, 3, 4, because all my y coordinates, I have a y coordinate of 4 on that line, and I need to be below that line. Below is less than, so I need all the points that are less than x of 2 and less than 4. Those are the two conditions I needed to write out. If I graphed both of those inequalities, let's do it in Desmos real quick. X is less than 2, y is less than 4. So over here, x is less than 2, boom, y is less than 4. There's our two boundaries, and this purple region is the one that we had shaded in, the one that overlaps the two. Perfect. If you understand both ways, you really understand it. Last thing we have left to do is to look at an application. So an application of linear inequalities is the following, and it relates to baseball bat length. So the National College Athletic Association, most people know it as NCAA, they regulate the length of aluminum baseball bats used by college baseball teams. The reason they use aluminum bats is because they're more cost effective than wooden ones, which break a lot. The NCAA states that the length in inches of the bat minus the weight in ounces of the bat cannot exceed 3. Bats can be purchased at lengths from 26 to 34 inches. So reading it one last time, the NCAA states that the length in inches of the bat minus the weight of the bat cannot exceed 3. Cannot be bigger than 3. If it means it cannot be bigger than 3, it means it needs to be less than or equal to 3. And bats can be purchased at lengths from 26 to 34 inches. Our first job is to write and then eventually graph a system of linear inequalities that describes the information given below. So they give us some hints. This is on the very last page of your notes. You don't have to write all this out. Just follow along. Let x be the length in inches of the bat and y be the weight. Those are the two things that we are measuring. From the given information, we know two things. We actually know, they told us, if I translate this this statement right here, I'm going to underline it in red. They told us the length in inches minus the weight cannot be more than 3. And we already said length is x, weight is y, so x minus y has to be less than or equal to 3. There's our very first inequality. They also say the following. Bats can be purchased at lengths from 26 to 34, so that means that their lengths have to be greater than or equal to 26. X was length, so length has to be greater than or equal to 26 or less than or equal to 34. So we actually have 3 inequalities going on here. We're graphing 3 boundary lines and then seeing where all of them overlap. And so my job is to graph it. And I already gave you the graph because I just want to show you what the graph looks like so we can interpret it. So when I graph it, this is what it looks like. And this is how someone could do this. What they're doing here, to graph this boundary line, best way is probably to solve for y. If I solve this for y right here, or I could use intercepts. If I solve for y and as I subtract x, I get negative y is less than or equal to negative x plus 3. Then I divide by a negative 1, and I get y is greater than or equal to. If I divide by a negative, it makes that be a positive. If I divide by a negative, it makes that be a negative. That is my inequality that they graph right here. It has a y-intercept down here of negative 3, has a slope of 1. And it's kind of hard to see how it has a slope of 1 in this picture, so that's why I gave it to you. But this guy is y is greater than or equal to x minus 3. So here's the region that they shaded in. And the region, this is the region shaded in, because it needs to be between 26 and 34. So here's my 26 inches. Here's my 34 inches. It needs to be in between those. It needs to be to the right of 26 and to the left of 34. And that's shown right here. And it needs to be above this line right here. And I can see that's above that line because it's greater than or equal to. So all of the bats that are this length in between 26 and 34 and in between these weights for y, so in between this weight and bigger, are going to be okay. One of the questions then they ask is, let's check a bat that is 31 inches long, so that means its x coordinate is 31, and weighs 25 ounces, and that is shown right here. Because that point isn't in my shaded region, in my feasible region, what it means is that bat would not be used by a player in order to meet NCAA regulations because it falls outside of my shaded region. If I picked a bat that was 31 inches in length but maybe a little bit heavier, so maybe 5, 10, 15, 20, 25, maybe it was 30 ounces. If it was 30 ounces, then that bat would fall right there. And because that bat is in my shaded region, that bat would be allowed. So if it was, instead of being 25 ounces, it was 30 ounces in weight, then the bat is heavy enough to be used. The problem is this bat is too long and too light. It would probably create an unfair advantage for that player. That is the end of our note packet and the end of actually our topics for Chapter 7. The assignment for the day is worksheet 7.6, which our guest teacher should pass out to you now. The numbers are numbers 1 through 19. I also supplied the answer sheet for our guest teacher to project on the projector once we get out of the video so that you can check your work. It's very important as you're graphing these that you show all of your work. And then we will look over both of these when I return the next day. So I hope all of you have a good weekend, and I will see you then.